So doing this atoms, molecules, I guess. Now we have semiconductor devices. How are you all doing? There's no response, guys. Yes, right. So do this question. Do the sixth one. It's nuclear physics, sixth one. Do the sixth question, guys. Radioactive sample at any instant has a disintegration rate 5000 disintegrations per minute. After 5 minutes, the rate is 1250 disintegrations per minute. And the decay constant per minute is. So if you see, you can get actually T half from this. So disintegrations are becoming how much? 1/4. So initially, I should take question number 6. Initially, dn naught by dt. dn by dt. Initially, normal dn by dt is lambda n. You know this minus lambda n, right? So this one is initially 5000. So lambda n naught is equal to 5000. We have e power, so n. So what is n value? N naught e power minus lambda t. N value is n naught e power minus lambda t when t is equal to 0. So this one becomes 1, right? When t is equal to 5 minutes, how much is the value when t is equal to 5 minutes? Lambda into n naught e power minus 5 lambda. Because t is 5, no, is equal to 1250. Are you able to understand this? I'll just join your student login. Give me a second. So he's asking the decay constant lambda. So if you apply, divide it. So 1 by e power minus 5 lambda is 5000 by 1250. 4s are. So e power minus will become plus 5 lambda is equal to 4. Apply logarithm. 5 lambda is ln4. Lambda is ln4 by 5. Right? So what is 1 by 5? 0.2. So 0.2 ln4. So ln4 can be written as ln2 square. 2 comes out. So 0.2 into 2, 0.4 ln2. Are you able to understand? This 1 by 5 is 0.2 ln2 square. 2 comes out, 0.4 ln2. Right, Nishant Saurabh? Others? Have people understood this? Next one, 7th one. I hope you understood. Do you guys got the message, Amrita? In nucleus with Z is 92. Z is 92. Emits following in a sequence alpha, alpha, beta minus, beta minus. So what happens? Beta minus, E minus will come out, electron will come out. Beta plus means positron will come out. Then Z of the resulting nucleus is. Z is the atomic number of the resulting is. So now, how many alphas? Count the number. Question number 7. It's like good one. Number of alphas. 1, 2, 3, 4, 5, 6, 7, 8 alphas. Then 1, 2, 3, 4. 4 beta minus. And 2 beta plus. Basically, because of beta minus atomic number will increase, and because of This one. Beta plus atomic number will decrease. So 2 beta minus will cancel 2 beta pluses will cancel 2 beta minuses. So net is how much? 2 beta minus 8 alpha. So due to 1 alpha, what will happen? The atomic number will decrease by 2. So 8 2s are 16. It will go down. Because of 2 beta minus, it will go up. Or if you say because of 4 beta minus, 4 it will increase. And because of 2 beta plus 2, it will decrease. So what is the net change? So net is 14, it will decrease, right? So Z is equal to 92. So what is Z dash? 92 minus 14. How much is it? 78. Am I right? Nishan Saur. So others, tell me the answer. Only 2 people responded. 78. Good. Srileka, Madhurani, BNS Kumar, right? No. Good evening. Yeah. Isha, right, ma. Which of the following cannot be emitted by radioactive substance during their decay? So you have alpha, beta, gamma, right? And beta plus also. We don't have protons. So that doesn't emit protons. Tenth one, which of the following has the lowest ionization potential? Cesium. Larger the size, easy for us to take out the electron from it, right? 11th one, conceptual. The wavelength involved in the spectrum of deuterium D12, right, are slightly different from that of the hydrogen spectrum because size of the two nuclei are different, nuclear forces are different in the two cases, masses of the two nuclei are different, attraction between the electron and the nucleus is different in the two cases. Attraction, electrostatic force is still the same, right? So what is different for both of them? The masses, right? Nuclear masses are different. 12th question, do 12th question, give a try. 12th question. The binding energy of electron in a hydrogen atom is 13.6 eV. The energy required to remove the electron from the first excited state of lithium. See, if this is nucleus, this is the ground state. So the next shell, so n equal to 1 is the ground state, n is equal to 2 is the first excited state. So first excited state means n is equal to 2. Second excited state, what is the n value? N is equal to 3. So you should remember this. In hurry, people will put n is equal to 1. No, n is equal to 2. So what is the formula for this? Z square into E naught by normally energy of n state is E naught, that is 13.6 into Z square by n square, right? So for lithium 13.6, what is the Z value? Hydrogen, helium, lithium 3 square by n is equal to how much? 2 square. 4 we have to put. Agreed? So 9 by 4 into 13.6. So 4 3s are 12. For 3.4, you know. So 36 3, 27 3, 30.6. Is that clear? The energy required is how much? 30.6 eV. Clear on? Is it clear, guys? 13th one, good question. Two-step question. A nuclear disintegrates into two nuclear parts, which has their velocities in the ratio. Let this be m1. This is m2. So one is velocity 2 v, other is v. Agree? That is what he is saying. The ratio of their nuclear sizes. Ratio of their nuclear sizes. So what will get this? Mass into velocity. Momentum is conserved. No, velocity gets cancelled. M1 by M2 is 1 by 2. So first we are getting the ratio M1 by M2. Clear? So from this, we know this radius formula. R is equal to R naught A power 1 by 3, right? So ratio R1 by R2, radius ratio is equal to R naught gets cancelled, A1 by A2 whole power 1 by 3. Now A is proportional to mass, no? A is nothing but mass number. So it is proportional to mass. So I can write 1 by 2 power 1 by 3. Is that clear? Why I said 2 steps? This is step 1, this is step 2. This complete one is only single step. So questions we can tell how many steps and all. So this is 2 steps question. Clear, everyone? Easy? Good question actually. Do 14th question. I'm trying to make it fast so that you can do quicker in the exam. If I go slow, you'll also do it slowly. So I don't want that to happen. The binding energy per nucleon of deuterium, H12 and helium is H12 is how much? 2 is here. Can even write this side also. That's fine actually. So H12 is 1.1 MeV and helium-24 is 7 MeV. If 2 deuterium nuclei react to form a single helium nucleus, so H12 plus, I just get used to this, is He24. Okay. Then the energy released is, so you have to find out the total energy per nucleons, right? So you have 2 and 2, so total 4. 4 into 1.1 this side, 4 into 7 this side, 4.4, 28. What is the difference? What is the difference? Right? S. Karthik, 23, right? Nishan Saro, right? So difference is 23.6 MeV, mega electron volt. I just want to tell you something in nuclear physics. If you know, basically, Earth core, there is a logic everywhere. It is physics, no? I just was explaining this to someone, a few days back. So we have this Earth, we have this core where we have iron and nickel ions, not the atoms, ions. So what actually happened, it's like we have these gases. Initially, when Big Bang theory happened, gas was there. So gas came together, that energy, whatever, it's not gas, gas is again atoms and molecules, energy was there. So energy has become proton and electron, right? Then these came together, like we have hydrogen atom first, then all hydrogen atoms got attracted because of the gravity. So they came together, all the atoms, they came together, and then the temperature got increased. So nuclear fusion happened. So when nuclear fusion happens, right? So further as you go down, if you go to sun, on the outer layer it is hydrogen, then helium. As you go down, further fusion happens and we have carbon and all. So as you further go down, we have heavier atoms, right? But if you see the nuclear stability, iron is at the peak. Iron and nickel are near to the peak. So that is why we have iron and nickel more at the core, not some cesium or uranium or whatever thing. So why we have iron and nickel more at the core? Because their nuclear stability is more, right? Nuclear energy per, energy per nucleon is more, right? And these things are under convection current, like the seawater. For us, we see seas at rest. But if you've seen Finding Nemo movie, inside we have currents, ocean currents, because of the salinity difference, temperature difference, the atmosphere and all, they move. Similarly, in the earth also, the iron, nickel, they move. So these are behaving like a charge carriers going in a loop. So charge current, it is nothing but current. Current going in a loop will produce magnetic field. That is producing the magnetic field. That is producing the magnetic field for the earth. Are you able to understand the logic behind everything, why that is happening? So these poles are changing. This is magnetism. So these poles are changing slowly, like 40 kilometers per year. They are moving, and generally around 3 lakh, on an average 3 lakh years, the polarity changes. So in one movie they show, like, this one magnetic field. So what is the use of this magnetic field? So sun emits the ions, right? These ions come and hit us. So because of the magnetic field lines, the whatever ions coming in, they get deflected to poles. So we are safer. So when this magnetic field is gone, right? We are no more, got this immunity. There is one video, man. So it's wonderful video. It's like, this is like a shell for us, helmet for the earth. As earth goes in space, there are these charged particles. These magnetic field is a shell which is actually protecting us. And if you see, sun is going like this, rotating and going, and earth is going like this in a spiral path. You know, you want to see in a video in this one, somewhere Insta or Facebook. So they're not exactly at rest. If you in your space, sun is going, sun is also not at one point. The whole thing is again going in the Milky Way. The whole Milky Way is again going in another route, you know. So it's like, see how beautiful it is, how they have designed or God designed or this happened. Are you able to connect the dots, guys? What I'm trying to say at the end of this physics, everything is interlinked. You know, you have to combine everything, nuclear, atomic, everything is linked. We are just trying to dissect and understand the concept. That's it. This nuclear, we can do a few more, but let us start off with this semiconductor devices which we got. Yeah, so let us do a few questions in it. Are you able to understand what I'm trying to say? Any yes or no? All right. So you should also try to connect the dots when you see some, physical principle happening outside, physics relevant, or fan rotating. If you observe DC motors, if you change the polarity of the battery, motor's direction will change. If you see AC fan, like table fan and all, right, sir? Right. So table fan and all, though you change the polarity, still the rotation of the fan remains the same. That is how AC works. And DC motor works as a dynamo, but AC fan doesn't work like a generator. There's a few things like real time scenarios which are happening in there. Question number 26. A circuit given below, A and B represent two inputs, and C represents the output. Circuit represents. So what is this gate? So how to give a try? So 1 1. So you have to give a try. I'm just telling you how to solve this question. So you 5 volts here. 1 means 5 volts. Okay. 5 volts here. Okay. 1 means 5 volts. So this 5 will come out. 5 will come out. So output will be 5. So let's call this AB and this is C. ABC. So 1 1 output is 1. If I give A5 and this is 0, still this will be 0. This will give 5 volts, right? So 5 is coming out. So 1 0 we are getting 5 1. Similarly, make A1 and B0, A0 and B1 0 1. We are getting output as 5 volts again 1. So what is this gate, guys? If both are off, we are getting 0. Which gate is it? OR gate. What is this? OR gate. Question number 23. Do question number 23. If a PN junction diode, a square input signal of 10 volts is applied as shown, then the output signal across RL will be. So in the forward bias, so basically in the first half, it is -5, no? That means it is in off state. Second half, 5 volts will only come. I'm not giving 10. So this will be 0, 5. 5 will come out. So what is the voltage about this? 5 volts. So, and when it is in reverse bias, when this is -5, I mean, this is -5 and this is 0, then we are getting 0 output. So this is the answer, option A. Are you able to understand? Yes, Karthik. Right. All of you are right. Wonderful. Question number 22. Question number 22. The circuit has two oppositely connected ideal diodes in the center. What is the current flowing? It's following in the circuit. Flowing in the circuit, I guess. Yeah. 22. So here, this is under forward bias. This is under reverse bias. So this is not working. Only this diode is there. 4 plus 2, 6. 12 by 6, 2. This 3 ohm diode is under reverse bias. This is 12 volts. No. So positive is coming. This is reverse bias. Yeah. Right, Nishant. Right, Karthik. Just trying to do the questions. 16th. In a full wave rectifier circuit operating from 50 Hz mains frequency, the fundamental frequency in the ripple would be. So 16th. So this is the frequency, which is 50 Hz. And output will be this way, right? And here it will be 100 Hz. If it is full wave, if it is half wave, what is the frequency for half wave? 50 Hz. So full wave means 100 Hz. Right, Karthik? Good, good. In a common base amplifier, the phase difference between the input signal voltage and output signal voltage, 15th. Common emitter is different from common base, guys. Right? So in this case, output is in sync with the input. As you increase the input, voltage, right? Your output will also increase. Am I right or not? So in this case, output will also increase. This is common base. What we have is common emitter. For common emitter, it is pi, if you remember. But this one is common base amplifier, so 0. If it is common emitter, it would have been pi. Are you able to understand 15th question? Yes. Anyone interested in saying yes? Thank you. 21. In the following, which one of the diode is reverse biased? So +5, 0. So this one is what? Reverse bias. +5 to this, 0 to this. 21. If you see here, this is +5 is fine, but this is more, no. So basically the difference matters. So this is also reverse bias. Huh? No, this is forward bias. This one -10, 0. So 0 is more than -10. Again, this is forward bias. So -12, -5. -5 is more than -12. So forward bias. 19th karo. 19th question. In a common base mode of transistor, the collector current IC is equal to 5.488 amperes. For an emitter current of IE is equal to 5.60 milliamperes. This is milliamperes. This is milliamperes. Right? The value of base amplification factor beta. For that, first, what is IB? IE minus IC. How much is it? 0.022. Am I right? Or 122? 122. Agreed or not? Just the difference. So beta is equal to how much? So what is this? In common base mode. So beta is asking. So normally what is beta? IC by IB. What is IC? 5.488 by 0.122. How much is it? कितने बच्चों? Sir, is it 0.122? So this is 12.112. 54 by 1. So 0.11. What are the options given? Oh, you have to calculate, man. All are very near. 48, 49, 50, 51. 5488 by 122. Simplify karo. You have to simplify. 5488 by 122. Do it. Sorry, 120, 112. So using calci, I got 49. They're very near. You have to simplify. You can go with 2 or 4 or whatever table you are good at. Go with that. Right, guys? Why you have to calculate for sure? Because all options are very near, or else I would have approximated very quickly. I just thought what is near to 50, but it is not that case. You have to calculate. So next one, let us do 18th. In the ratio of the concentration of electrons of the holes in, so it is not in the ratio. If the ratio number of electrons to number of holes is 7/5, and ratio of currents I of electrons by I of holes is 7/4, then what is the ratio of the drift velocity? This is formula based question, guys. So I is equal to NEA VD. If you remember, NEA VD. VD, A is the area, E is the charge, N is the number density, VD is the drift velocity. So I of electron by I of holes is N of electron by N of holes. E gets cancelled, A gets cancelled. V drift of electron by V drift of hole. Am I right? So if we substitute 7/4 is equal to 7/5 into V drift of electron by V drift of hole. So VDE by VDH is equal to 5/4. Able to understand? This is the formula we have to use. Remember this formula and solve. Akshini, right, ma? Karthik, right? People are doing great, man. 14th question. The electrical conductivity of semiconductor increases when the electromagnetic radiation of 2480 incident on the band. So 1240 by 2480. Am I right? Question number 14. 1240 by 2480. So 0.5. So we remember, no? 1240 EV nanometer. So 0.5. Easy. When the PN 13th one, when the PN junction diode is forward biased, then what happens? The depletion region is generally forward bias mode, depletion region will be decreased, reduced is right. And the barrier height is increased. No, even the barrier potential will decrease. Depletion region is widened and barrier, no, both depletion, yeah, this one. So see, both the depletion region and barrier height are reduced. Option C, right, guys. Let us try 25th. A working transistor with its 3 legs marked PQR. So it is like experimentation question. So PQR is tested using a multimeter. No conduction is between P and Q. P and Q, no conduction. By connecting the common negative terminal of the multimeter to R. So this is the negative terminal. Multimeter we have negative terminal to R and other positive terminal to P and Q. So you connected positive to this and then check. Some resistance is seen on the multiplate. Which of the following is true for the transistor? So R is, if you're keeping this, both are positive and some resistance is given. NPN transistor, right? So this is, no, PNP, yeah? PNP transistor or NPN, some resistance is found. So basically, PQR, if I have this, or this way, P and Q should be far when there is no resistance between P and Q very high. R is between them, right? So R is base. Is R base? Say by connecting the common negative terminal. So R, no. I'm not sure. by connecting the common negative terminals of the multimeter to R and the other positive terminal to P and Q. Some resistance is seen on the one. Which of the following is true for the transistor? NPN with, I just give as a try. R is collector. Then how come then P and Q will have a conduction, no? R should be base, no? Am I right or not? So normally PQ doesn't, no conduction means PQ or far means one is emitter, other is collector, and this is base. So R should be the base. This is what I feel. R is the base, and from R and P, so this is negative, this is positive. It's like a diode, no? So you are getting the resistance. So option B, it is an NPN transistor with R as base. Am I right? Twenty-fifth. They're actually doing very fast. I don't know whether you are able to understand that or not. This is not there now. They are not asking these days out of syllabus. By increasing the temperature, the specific resistance of a conductor and a semiconductor. So conductor will increase and semiconductor will decrease. Conductor already it is conducting. Collisions will increase. So the resistance will increase, or conductor, what is asking is specific resistance will increase. And for the semiconductor, it will decrease. At absolute zero, silicon acts as. If you take metals, absolute zero, they are superconductors, we say. But silicon, at absolute zero, whatever electrons we have, that is due to temperature. So when you have absolute zero, all the electrons are bonded and it behaves like a insulator. If it is a metal, it behaves like a conductor because free electrons and all, they are more conductive. But if it is insulator, it is this way. The energy gap is maximum in insulators. The part of the transistor which is most heavily doped to produce large number of majority carriers is emitter. These are very easy ones. Okay. So I guess this much only in this. Let us go back to this, our questions. Send me this one. Right, Saurabh. To the 15th question. An alpha particle of energy 5 MeV is scattered through 180 degrees by fixed uranium nucleus. The distance of the closest approach is of the order of 15th one. So 5 MeV is equal to KQ1 Q2 by R, your potential energy. You understood? So convert that, substitute Q1, Q2. So alpha particle, so what is Q2? 2E plus. Uranium nucleus. What is the uranium? What is the charge of uranium, guys? 92E plus. E means 1.6 into 10 power minus 19, coulomb. Substitute that, K is 9 into 10 power 9. Are you able to understand how to solve the question? Distance of closest approach, guys. 10 to 20 centimeters. 10 power minus 12. Okay. Kinetic energy into potential. Nishant has solved. So 10 power minus 12. Others, can you just give a try once? So 5 MeV, 5 into 10 power 6 into 1.6 into 10 power minus 19. Then 9 into 10 power 9 into 92 into 2 into 1.6 into 10 power minus 19 square. So the square is gone by R. Right? So R is equal to 9 into 92 into 2 by 5 into 10 power. Here minus 19 and 9. How much? Minus 10. Minus 10 and 6. Minus 16. The 6 comes the other side, no? So do this. So just seeing the powers. So 9 can be written as 9.2. 9 into 9.2 into 2 by 5 into 10 power minus 15. 9 nines are 81, right? 81.18. So 82 or something into 2. 160 by 5. 160 by 5 is how much? Around 30. So what is the answer? So 10 power minus 14. So you're getting 10 power minus 14 meters. So 10 power minus 12 centimeters. They should have given 10 power minus 14. We would have marked it in a flow. So this is where units and measurements, we do mistakes, no? So if we approximate it, it is some 3 into 10 power minus 14 meters. But we have to write in terms of centimeters. 16th, if the radius of aluminum 1327 is estimated to be 3.6 Fermi, the radius of, this is not aluminum, is it aluminum? 52 125 nuclear will be. So how to solve this? 16th one. 3.6 is equal to R naught A power 1 by 3, 27 power 1 by 3. R dash is R naught into 125 power 1 by 3. So R dash, what is R naught? 3.6 by 3, because 27 power 1 by 3 is 3. Yeah, this is 5. How much is it? 1.2 into 5. How much is it? 6. Able to understand this? 6 Fermi. 70. The intensity of gamma radiation from a given source is I. On passing through 36 mm of lead, it is reduced to I by 8. The thickness of lead, which will reduce it, the intensity to I by 2 will be. 17th one. Do 17th question. This is based on some assumption. This is based on some assumption. So what is the assumption? If you're assuming that it's going linearly, ante I becomes how much? I by 8. So 36 mm. If it is going linearly, but it doesn't go to linear, right? Generally. Have you got it, Karthik? 12 mm? You are going linearly. So I has to become I by 2. So if you remember, we have logarithmic this one, like time t halves, like nuclear t halves, no? So I by 8, that means what? First I has to become I by 2, then I by 4, then I by 8. So x here, x here, x here. So 36 means 12, 12, 12. I2, I by 2 is 12. Is it clear? Very easy. Right, I is log. That's true. So basically, I is I naught e power minus lambda x. Just like our n is n naught e power minus lambda x, no? Same thing. That is how we got 12. It's like 3 t halves I'm taking, basically. So the same concept being asked in a different way, right? Yeah, I by is e power minus kx, right? You're right, man. Question number 19 or 18th. Starting with a sample of pure copper, 7/8 of it decay into zinc in 15 minutes. 7/8 means how much is left out? 7/8 is done in how much? 15 minutes. That means n has become, how much is left out? 1 by 8. That means 3 t halves. So 15 is 3 t halves. So t half is how much? 5 minutes. Right? The corresponding half-life is 5 minutes. Do 19th question. The diagram shown shows the energy levels of an electron in a certain atom. which transition should represent the emission of a photon with most energy. So basically 4 to 1 is the highest. It is not there. Then 2 to 1, 3 to 2, 4 to 2, 4 to 3. So 2 to 1 is more. 2 to 1 is more. Then comes 3 to 2. Then comes 4 to 3. But he gave 4 to 2. So 4 to 2 is more than 4 to 3. But it is not more than 2 to 1. Agreed? 19th one. A nuclear transformation is denoted by X, N alpha, lithium 37. Which of the following is the nucleus of element X? 20th. What is the meaning of this 20th? X, N comma alpha, lithium 37. So the meaning is X is an element. If you are adding a neutron, it is giving an alpha. Alpha is how much? Alpha is helium 24 plus lithium 37. Now balance it. 2 plus 3, 5. 4, 7 plus 4, how much? 11, 11, 1, 10. Agreed or not? So it is boron 510. Yeah, so X undergoes transition if you're adding an alpha and this is coming. That is the meaning of that. 21th, an alpha nucleus, energy half mv square, bombards a heavy nucleus target of charge, ZD. Then the distance of closest approach of the alpha nucleus with the will be proportional to kinetic energy. So we just 21. P is equal to K. So K Q1 Q2 by R is equal to half mv square. So R is proportional to 1 by V square or 1 by M. 1 by V square is there. 1 by V square is not there. V square is there. So 1 by M or 1 by M. So mass comes to the denominator. Option C. Right, man. 22. The energy spectrum of beta particles N of E as a function of beta energy emitted from a radioactive sources. Textbook 1. D. You're right. Nishan sir is on full swing, man. It's good. Good. You know, when people answer the questions. When lithium 37 nuclei are bombarded by protons and you get connected to one. Oh, it's NCRT. Yeah. Nishan, Saurav, Isha, right? I just wanted why I didn't share everything before, but I want to see who is serious and all, who is left out at the end. They are more serious. So whoever 32 out of 32, I guess 30, maybe leaving me and the admin. So 30 of you are very serious, I guess. Got very good chances. Try to be in touch with us. Okay. So I already told you my Insta or FB. I have a page also, Himatesh Jami. Like students made it and I took it from them. So there also people do share questions with me, I mean, you know, and all can get connected over there. The emitted, yeah, resultant is beryllium 48. So atomic bombarded with proton. So proton is how much? H11, na? So 4 and 8. The emitted particle will be. So it is balanced. Only energy. Energy is what? Gamma photons. 23rd one. 23. He said lithium 37 plus hydrogen 11 proton gives beryllium 48. It is balanced. With that, something is there. He's saying what it can give is gamma photons, right? Gamma photons. It would go. Let us see. Anything else is there? We have semiconductors. We did practical physics. We have solved papers. 2009. Okay. You want to take this as homework, guys? Want to give a try? Huh? All right. Can you take screenshot? 2009 solved. I'll also give you solution, no issues. Take the screenshot. Homework, take a screenshot. Someone, if you say yes, I'll go to the next page. Screenshot done. Yes. Next page. Screenshot. Done. Right. You can actually get this online also. Just give sharing it so that you will, solve it. It's like check mark for you, right? You can also solve this, no issues. Take screenshot. Isha, Gudma, Akshini. Done. Right. So I'm sharing the explanations also. Take the screenshot, guys. Srileka, Karthik, done. So don't check the solutions directly. I'm not asking you to check whether it is right or wrong. You solve. When you're not able to get the answer, then check it. Then understand. You'll enjoy it. When you work on something, then you'll appreciate, or else you won't appreciate. The screenshot. Right. Next one. Take screenshot. Is it done? Last one, last page. Right. So actually this paper will give, I guess that is enough for now. Next class, if we have, we can solve the other papers. We have 2010 and then 11. Oh, nice. Then more questions are here, I guess. Oh, this is chemistry. So physics part again. So if you're having next class, I'll do these two more, this one. Is that clear, everyone? Right? This is the homework for you guys. So we still have wonderful time. It's like start of the Feb. We have 2 more or 3 more months for you for multiple attempts. Just want you to, talk to you and know what is going on with you. EMI, rotational motion, and electrostatics. We'll discuss and let you know. So whether we'll be continuing and all. So did you ask the management, guys? So please do check with them, right? So let them know if you want more classes and all. We'll definitely go ahead with that. But irrespective of this, you should see whatever time you have spent now, should not waste this momentum you got, right? So please work on it. Do more number of questions. Okay. Practice as much as you can. That helps you a lot. As I said, previous 42 years questions, previous 42 years, few of you has got it. Others also still you haven't got it. Try to buy that and start working on the questions, previous IIT JEE questions, right? Mains, if you do mains level, that would be great. You'll understand. You'll understand if you keep solving it. If you don't, yeah, it is difficult. If you just, don't spend time on it and all, it is difficult for you. I'll be there. You can be in touch with me if you want real, support, guidance, or whatever. Right? Let me know. I'll try my best to help you out. Okay. I say with practice now I got speed in problem. That's it. That's what is coaching all about. So we practice. What happens during practice? You know where to approximate, where not to, and you remember the formulas, right? So it saves you time in exam. You get exposed to different types of questions that changes the way you think. Suppose someone facing problems in childhood becomes much stronger and successful in future. Someone who got pampered a lot in early stages might not be, right? Because they're learning now. So That's how life is. So practice more. It will help you a lot, right? Any more questions from anyone? Karthik? Any questions? Sir, will more of this crash course be taken? Srilekha Mudunori. It depends, right? If more of you are interested, right, it might be continued. So again, consult the management, Amrita, right? You can send a mail or call them or however way you can, get in touch with them. Let them know. So based on that, they'll decide based on the number of, people who are interested. They might think of extending or, starting another session wherein you can do much deeper. Again, this has to be given. I heard they are sending you mails. So please check your mails. If it's not there, mail them. I guess they are getting the sessions edited for you people. Okay. So check with the management. They'll send it to you. Regarding exam or anything, how to prepare, any questions as such you got. This last session. So for physics, I'll be setting the paper. I'll be submitting that. So I guess they might have informed you we'll be having an exam, right? 30 questions for complete paper, 10 from each, subject. Any more questions? Let me see the names who all are here today. We did actually well. If you see the number of problems we used to do before and now, we are just faster and you're able to get connected, right? Achyut, Akshini, Anuranjani, Harishwar. Okay, for sure. Right, that's it. Done for the day. Okay, guys, all the best. Work hard, do practice as much as you can. Again, I'm telling you, every day it is like 8 to 12 hours. If you target, at least you will prepare half of the time. If you target 3 hours, you'll prepare 1 hour. So you should keep your targets high, work hard, and it can be done. How to master inorganic chemistry? Or forgot. Okay. I used to follow JEE. JEE is one book because their logics are given, and NCRT is they give kind of fact. So if you are not able to understand that, practice again, man. JEE helped me a lot. I got around 130, I told you, right? So JEE is the one. And for organic chemistry, Morrison and Boyd, SN Samuel. And for physical chemistry, I used P. Bahadur. And we used to have assignments given by our sir. He used to teach us. So we got less time. Revise the textbook as many times as you can. Revise the textbook. And that salt analysis and all, the process is there. No color test, smell test, basic analysis and all. Then you go for anion, cation, or cation, whatever that is. I actually forgot. So you kind of eliminate one by one and all. These days, the questions are kind of organic, inorganic, mixed questions are coming out. Okay. So again, practice. Question, Karthik. Two trains A and B are moving with, I got a question. I face difficulty in rotational motion and kinematics. Practice, ask doubts, get it clarified. So or discuss with your friends, do combined studies, get it done. I just got a question. Two trains A and B are moving with speeds 20, 30 respectively in the same direction on a straight track with B ahead of A. So B is ahead and moving faster 30, A is behind and 20. The engines are at the front ends. The engine of A blows a long whistle. So the one behind is blowing the horn. Assume that the sound of the hustle is composed of two components varying in frequency. From F1 is equal to 800 Hz to F5 is equal to 1120 Hz as shown in the figure. The spread in the frequency, highest frequency to lowest is the 720. The speed of sound is 340. Distribution of sound intensity of the whistle as observed by the passenger in the train is best represented by. Where are the options? You mean the range? Do for 800, do for 1120 separately. So what is the formula? F0 into V plus Vs, VO by V minus Vs or whatever. So velocity of sound is 340. In the numerator, observer is going away. Observer is going away, so I have to put minus 30 in the numerator. And in the denominator, source is coming nearby. So minus 20 in the denominator. So 340 minus 30 by 340 minus 20 into 800 is the lowest frequency. If it is the same into 1120 is the highest frequency. Are you able to understand, Karthik? Karthik, right man. Easy, see. Just like that it is done. So 340 minus 30, 310. 310 by 320. Am I right? 31 by 32 into 800. 31 by 32 into 1120. So 32 and 800. 16 twos are 1650s are. Or 32, how many times is it? 1/4. 25 times. So 8 fours are 32, no? So 32, 25 times is 800. Am I right? The first one is 25 into 31, the lowest frequency. 25 into 31. And the second one, 1120 by again 32. How much is it? 320. Tens are 35 times. 35 times 31. See, done just like that. Using numbers we solve, no pen, pencil, nothing. 31 into 25 to 31 into 35. Am I right, Karthik?